Hi everyone, I'm Valeria from Valeria's team or team Chemi-Rockstars. We are students from Preparatoria de the Universidad de Guadalajara, and now I'm going to explain you our resolution for this problem. Just test. First, I'm gonna give you some context about this problem. So the problem statement says, while every school student knows about a qualitative test for an outlet, it may also be important to know how much outlet you have exactly. So this problem asks you for a quantitative method to determine the amounts or concentration of outlet in different types of cheeses. According to a series of studies carried out by researchers, the vast majority of cheeses contains these following outlets: 2-methylbutanol, 3-methylbutanol, and acetaldehyde. This is almost a rule. Well, we can verify this information to the nuclear magnetic resonance method. The nuclear magnetic resonance spectrum of a molecule forms a pattern that points to its identity, and its interpretation is based on recognizing the characteristics waves or peaks of a spectrum. Using a virtual simulator of magnetic resonance, we found out the spectrums. The first one is for 2-methylbutanol. The second one is for 3-methylbutanol, and the last one is about acetaldehyde. And these spectrums were made using magnetic resonance with carbon-13. And in the next slide, we can observe exactly the same compounds and in the same order. But now, these spectrums were made using hydrogen bond. Of course, all these graphics are only for illustration, and our solution is based on this. The Weber equation. The Weber equation is very common and very important in spectrophotometry, and this is because it relates the absorbance of a solution with the molar extinction coefficient, the cubic peak length, and the concentration. And you can observe the unities of each variable. Once the identity of the compounds has been confirmed, we use that equation, the Weber equation. And it is very important to previously know the identity of each compound because every substance in general will have a different molar extinction coefficient. Now, the first step of our solution or our method is to obtain the constants or molar extinction coefficients. A standard solution of the compounds of which the concentration of outlet is already known can be used to determine their molar extinction constants. So solving for the Weber equation, we get this new form of the equation. And another important thing to know is that the data for A, absorbance, and B, cubic pitch, must be given by a spectrophotometer. Talking more about the constant, for acetaldehyde, only one constant is needed, but on the other hand, for the 2-methylbutanol, the 2,2-methylbutanol, two constants, two different wavelengths would be needed. And this is because the two molecules are very similar, so their absorbances could overlap in the graph shown by the spectrophotometer, like in this case. If you pay attention to this graph, you can see we have two different compounds. This is the compound X, and this is the compound Y. In our case, those compounds should be the 2-methylbutanol and the 3-methylbutanol. Now, we need to observe this. Their absorbances overlap in 2 points. This is the first point. This is the second point. This is the reason that we need to have 4 different constants only for 2 compounds. This is the first constant, the second one, the third one, and the fourth. We also can observe that you have 2 different wavelengths. There's 1 and there is 2. So taking into account the constant for the acetaldehyde, we will need in total 5 constants. And the last step of our solution is the determination of actual concentrations of outlet in different types of cheeses. After obtaining the previous constant, the concentrations can be determined. And first we need to clear the equation again. And in the case of acetaldehyde, the equation that relates the concentrations with the absorbance divided by the product of the molar extinction coefficient multiplied by the cubic pitch is enough to get the concentration. But in the case of the other two aldehydes, namely the 2-methylbutanol and 3-methylbutanol, simultaneous equations must be used. In the right side of the presentation, right here, you can observe the simultaneous equation, where the only variables or only variables are the concentration for the compound X and the concentration for the compound Y. So after doing a lot of mathematical calculations and clearing this equation, you can obtain the concentration of the both compounds. So this is only theory and not practice. I'm not going to show you how to clear this equation, but you need to do that. And now, at the end, the concentrations of the three compounds are added to obtain the total concentrations of aldehydes, and that's our conclusion. But finally, I added a last slide here, so you can check my references. Thank you.